So
Are
here
you
is,
gonna check the problem?
okay. So let me say this about the homework. So I'm starting a new policy up until, we'll do it until Christmas and see how it goes. So in class, and I call these, oh, you're not seeing my screen. Let me turn the screen on. Hold on. Share the screen. All right, so I'm calling these Dolphin Points because it's a dolphin stamp that I come around and give. And so it's 2 points per stamp. And so at the first of class, they get out, everybody gets out their homework, and I come around and stamp the problems that they worked. And like today, there was 3, they got up to 3 stamps today. So, and each stamps were 2 points. And it's not just pure bonus. You can get bonus if you do the minimum. The minimum will be 10 stamps between now and December 16th. Now, that works well for kids in class, but then what about virtual kids, right? So I just, before we got on, I made a spreadsheet of virtual kids, and I've got to find a way to give you points for attempting the homework without getting 20 emails a day. That's a pain in the butt. You got to open them all up, mess. So I thought, well, you can hold them up to the screen in the Zooms, and I can just look real quick, but then that's taking up time for the Zooms. So I don't know how I'm going to do it with virtual kids, because I think there needs to be an accountability. I've always had an accountability with homework. Like I've always gone around and give stamps, at least for the last 4 or 5 years, at the first of class, not every single day, but 2 or 3 times a week. So it really works well because kids do want to get the points. Otherwise, why do homework, right? Why not just wait till the night before it's due and then do a marathon session and do 7 sheets at once and not learn anything? Because that's the way human brains work, right? Procrastinate till the very bitter end. So I have not figured out a way to do it easily with and then if I just do it on Zoom, what about those virtual kids that are working right now, or they have other schedules, they can't be at the Zoom? That I suppose is not fair to them. So maybe we'll have you submit it. I don't know how to submit it yet. I don't know how virtual kids are going to submit it yet. If you guys think of a good way to do it that's not incredibly time consuming, you don't want to have to take a picture of every time and then attach it to an email and then send it to me. That's ridiculous. It's a lot of work. But maybe that'll just be an in-class thing. I don't know. So you all, so I'm saying all that, and I haven't decided how I'm going to, but you ought to keep working on them, because eventually you're going to have to, maybe once a week. How about that? For virtual kids, like by Sunday, you have to have sent me, put them all on one page or something and send me 1 email a week. That'd be easier to handle than, Okay, so if you guys think of something good, let me know. Now, you all said you had questions about them. And this is for 212. 7, A, B, C, and 8. Right, those on 1. Okay, so any questions? We didn't really go over these in class. I went around and I checked them, but we didn't really go over them. I'm going to post a key on it as soon as we get done. So we got, that's probably another couple days. There'll be a key posted by the weekend for 212, with me working out all the problems. So I can answer, I guess, a quick question. Anybody have a quick question on 1, 7, or 8 from the homework?
On number 1, I started like plotting the graph and stuff.
Yeah.
And then I got stuck and like I couldn't figure out how to like find the average velocity. Do you just use the orange equation like the other problems and like not even pay attention to the graph?
Well, you can do it, but the average velocity is basically a secant line. So if your graph looks something like this, it's going to be parabolic, and you can just do the T chart, then you'll get some kind of parabola, something like that, or whatever. Then the average is going to be the secant line, which is from the very beginning and very end, and you connect those 2 points, and then the slope of that is the average. And this is all shown on the key, but the slope equals V bar. Can't read that very well. So the slope of that line equals V bar. So whatever that rise over run is, that's like a very poor estimate of the velocity of the ball, as we know is increasing. So slope of this orange line equals V bar, equals average velocity. And then to find the tangent, you have to take a straight edge, a ruler, and you got to, you know, kind of guesstimate. We'll assume initial is 0, I guess, and then the final, you do a tangent line there. And I'm winging it here, but the key will have it right. And you find the slopes of each one of those. Now, if you're in calculus, you have an advantage because the slope is the derivative, but you're supposed to kind of just think through. This is really a repeat or review of a previous worksheet where we were doing that. Like we come up with the equation V bar equals V naught plus V final over 2. I'm recording this. Yeah. This is from the graph, the average, that's the average secant line, draw the tangent lines. Okay, did that 1 and 2 seconds. I did it at 1 and 2.5 seconds, and estimate the instantaneous velocities at these. So you end up, your function is x equals 2t squared. And we're going to learn later that the power rule, which would solve this immediately. But I'm trying to get you to think through the graphical version before we get to the power rule. Yeah, anyway. So it'll be somewhat of an estimation on these green lines as to what those slopes are. And I also guesstimated what the purple parabola looks like. I didn't plot points, but you got to plot points here to get more of an exact answer than what I'm giving you. I'm just kind of giving you a ballpark without giving too much away. I'm going to still do homework. And then Rose, you said 7 was giving you trouble?
Yes.
What, 7A, B, C, or what?
7A.
Object initial velocity. So we know that, let's get to that. Am I looking on the virtual? Hold on a minute. No, I'm looking at third hour. Daggone it. Here's the virtual. Okay, so let's see. So for 7A, we got the way I would attack it, how we attack it in class. This is an initial velocity, so that's V naught. Circle and label, right? CL depot. Acceleration is this is A, and then time. What's the total displacement? So we're looking for delta X. So you go, okay, well, this looks like it's a second orange equation, right? So CL depot. So the second orange E stands for write the equation. So we have delta X equals V naught T plus 1/2 AT squared. And then looks like it's already isolated. So we're just plug and chug. Now I keep this in the CGS system. And that stands for centimeters, grams, seconds. Don't convert it to MKS. Don't convert it to meters, kilograms, seconds, because there's no reason to. What's the answer? The answer is in centimeters, right? Please tell me. Yeah, the answer is in centimeters, so might as well just leave it in centimeters, grams, seconds. So to find that, I had a couple students have trouble on this, and it turns out that they didn't square the time on the end. That's why I asked you to square your time. So then delta X then equals 20 centimeters per second times 5 seconds plus, my handwriting's atrocious, apologize, 8 centimeters per second squared, if I'm in a hurry. I don't know why I'm in a hurry, but My buffering is killing us here, so I don't need to be in a hurry because it's the computer's slow as it can be. All right, so I'm having memory issues. There's too much. I got too much on this iPad. So this time here is 5 seconds, but I got to square it. So Rose, if you did that, you should get 200.
Yeah, I just worked it out again.
Oh.
I got 200.
Okay. In the first second, you know, you just plug in 1 for time and then see what you get. Get rid of that. Don't do that anymore. Plug in 1 for time, and then for 7C, you plug in 4 for T, then you plug in 5 for T, you subtract the 2. Okay. And it looks like on the 8, you're going to use the third. Yeah, an 8, you use a third because there's no time. If there's no time given, you use a third orange equation. Okay, tonight, the homework will be number 9 and 10, 9A, 9B, and 10. And so this will be for a dolphin, a dolphin, a dolphin. Well, for in-class kids. That's tricky. Virtual kids. I don't know yet. I mean, it may just be that I'll just leave those blank on the, at this point, my thinking is that I can't really do stamps with virtual kids. And so I would just leave that as blank, and it wouldn't hurt you, wouldn't help you. It's a good chance for bonus, because if you're a good homework person, you're always doing your homework, you're keeping up, you should get bonus for that. You should get, you know, your due. And it's not fair to you that you wouldn't get a chance at bonus, but you may not need it. I don't know. I mean, I'm having a hard time communicating with a lot of virtual kids. To get them to show up once every couple of weeks is amazing. You know, so they're not doing well, but you have to actually put in some effort. So some of them are working and they just kind of gave up, but that puts them even further behind. So I don't know. Okay. So that's the dolphin thing, and we'll still think about that. And I welcome your ideas. Uh-oh. Sorry, my wife's calling me. She don't usually call me. Hey. No, I'm Zooming right now. Well, it's important. Okay, bye. All right, so I showed the pilots. I showed you guys the pilots yesterday, and I showed that in class today. We showed more of the pilots. It's really pretty good. But I don't know if I want to share that screen. Oh, I put the okay, so I decided this, and I'll show, I guess I will share the screen. I want to show you this. Let me stop this sharing. So and I'll share my other screen. Let me find it. Yeah. Okay. So on the home page, here we go. Now I'm going to share it. I had grades in there to get rid of that. Okay, boom. So on the canvas, on the home screen, the announcements. So here's, can you see this? Can you guys see it? Can you see what I'm looking at?
Yeah.
Okay, you see Feast and Film? Okay. Up at the announcements, like when you click on this, here's the link to the Girl in the Jeep video, which we're going to go over towards the end here. But up here, where you click on this, that'll take you to any links and anything we did in class, like a video. This is how a human centrifuge works. And this is the video of these pilots' faces. And you ought to watch, only 4 minutes, you ought to watch that. It's really interesting to watch them go in the centrifuge and go into all these G forces. And we kind of looked at it yesterday, but we talked about it more today. So that the point I'm making is at the top of the homepage, if there were links, we also talked about the Concorde in second and third hour. And so here's a link to the Concorde article I referenced. Concorde was a French jet that went up to above Mach 2. And we talked about Mach numbers, Mach number being speed of sound. And so these are the important links from class. Okay, so click on those, and you just look. Not every day, we won't have them every day, but when we do, that'll be a good place to put them, because everybody goes to the homepage, I guess. First thing you see, I think. So you should just look right at the top, and it'll tell you any kind of links, important links. And I can only put 5 announcements at a time, so they'll kind of lop off after 5. Okay. Is that it? Well, I'll come back to the screen here towards the end when we talk about Girl in the Jeep. Okay. Back to the, now Pepper, this is the heck of a day. Now Pepper squealing downstairs. She got me something. Pepper is blind and deaf, so she can't, so she walks around the house, and then she gets into a corner, and she doesn't know how to back. She's forgot, she's learned, she doesn't know how to back up. She has dementia too, so she can't back up. So she gets into a corner, and then she sits there and cries until you come get her. So I think she's in a corner right now. So we talked about, let me just throw this out there. This is all came naturally from discussion. It's hard to recreate a discussion, but we talked about this. This is that bullet coming out of the gun. And so I think this is probably third hours. That's third hours, but then here's ours from yesterday, what we talked about. And we had a good talk. We talked about Cedar Point, talked about G's, talked about John Glenn, Stapp. And then, but in third hour today, we expanded on that a little bit, and we talked about, I have some kids in there that they like this whole military stuff. So we talked about Blackbird. Blackbird, or SR-71, is a spy plane. It's not a bomber, but it's really cool looking. Yeah, look it up. I ought to put a picture of it. I have one hanging from my ceiling in my room. And so we talked about it. It flies, as last time I checked, and it's classified, but it flies at Mach 3.7. So remember, a Mach number is 331 meters a second is the speed of sound. And that's the speed of sound at sea level. In air, in normal air, you have to clarify all this. So at room temperature, on normal temperature, at sea level, and Oklahoma's not quite at sea level, so we're a little bit slower. The less dense the air gets, it changes speed, like speed of sound anyway. Like water, the speed of sound there is around three times what it is approximately in air. So sound waves travel 3 times as fast in water. They get attenuated. They can, but then whales with low guttural sounds can go, hundreds of miles. They can talk to each other through water. Depends on what's between them. But so sound waves, Mach 1, named after Ernst Mach, in honor of Ernst Mach. It's 331 meters a second. It's about 746 miles an hour. And so someone asked, well, how fast do 747s fly? And they fly at around 570, 580. So let's just round to 600 miles an hour. And they said that's not quite Mach 1. That's about 0.8. But then someone asked, well, what's the fastest plane? I said, well, that's the Blackbird, which flies. And the Blackbird's been around since the 70s. Actually, I think even the late 60s, perhaps. Now, we use it to spy on mostly Middle East, Russia, China, and North Korea. It flies a pattern up there, and it flies at 80,000 feet. I think somebody read that off to me today. I think it's right, 80,000 feet. Now, okay, good. She's home. So Jamie can take care of Pepper. Okay, so like 747s fly around 50,000 feet. I'm waving my arms here, but in that range. So the Blackbird flies at 80,000 feet. One, so it doesn't get shot down. People don't like being spied on, turns out. And two, you can fly up there a long time because there's not as much air. So air doesn't get in your way. Air doesn't seem like it's a problem, but if you go fast enough, it won't get, it cannot get out of the way, and it gets really hot. All that friction occurs. I think I mentioned this today and maybe yesterday. The air in this room can kill me. If the air in this room gets organized, it will kill me. It's kind of weird to think that, but the air in your, look around you, the air molecules are just, you know, they're benign. They're just floating around, Brownian motion, bouncing into each other, total chaos. Brownian motion is something that, I'll throw it out there. Brownian motion. We had some long discussions today. So I'm trying to, all the stuff we talked about in different classes. Brownian motion. Brownian motion is just this. When I think of Brownian motion, do this. It's the random, it's named after a guy named Robert Brown in the 1820s. He was a biologist, and he noticed that in his microscope, he noticed that these little pollen grains and stuff were bouncing all around, and he thought they were alive. And it wasn't until, it wasn't, the person who finally figured out Brownian motion, why that happens. It was Einstein, early 1901, 1902, 1903, in that range. He wrote a paper in 1905 about it, and it basically used it to prove that atoms are real. So that's Einstein for you. Anyway, so Brownian motion. So the particles in the air right now are in Brownian motion. They're just bouncing into each other totally randomly. They move at around room temperature, around 800 miles an hour. But they just don't get very far because by the time they go about a nanometer, they hit another particle. So they bounce. So this bounce around, bounce around, bounce around. But what I'm doing with my larynx, and you're hearing me, you know, it goes through all the computer and wireless, etc. But when it comes back out, your speaker, your little woofer, it's vibrating that air so that you pick it up with your ears. But the point is that this air, even though it's overall Brownian motion, it can become extremely organized. Otherwise, we wouldn't have sound waves. So it becomes extremely organized instantaneously. And I was laying in bed thinking about this last night. Why? You can't take marbles and do that. You can't move marbles around or BBs, because they're too massive. Air molecules are O2s and N2s mostly, right? Diatomic oxygen and nitrogen. And so they can change direction and speed up and slow down. It's called conservation of momentum, but they can do that because their mass is so low. And so that's why air molecules can just instantaneously. Okay, so what's this have to do with all this other stuff we're talking about? And this bullet in a barrel. Well, that bullet is riding a concussion wave that came from an explosion behind it, you know, with the gunpowder that exploded, which drove the bullet out of the barrel. But that's because that air got organized inside and pushed that bullet out. You know, like bombings that blow windows, they blow windows out of other buildings, and there wasn't no shrapnel. It's just air. So air is really interesting. Okay. But when you go up, when it gets thin, like if you're on top of Mount Everest and you're trying to talk to each other, it doesn't carry because there's not as much air molecules to form. These air forms areas of rarefaction and areas of compression. And these little compression areas are what the wave fronts are. And they're standing waves. Like you blow a musical instrument, it produces standing waves inside a piccolo or a trombone, or you adjust the valve to change the standing wave. But it's still just a matter of manipulating air. Yeah, isn't that nuts? I mean, I would miss that. There's no sound on the moon. You know, you don't hear things on the moon because there's no air. So now what you do is you get a bubble and you'd fill that full of air, produced it somehow, oxygen, nitrogen, and then you could hear each other talk. But when you go outside, you can't hear anything. Anyway, well, I don't know how I got off on all that, but all right. Does that produce any questions from you guys? Sometimes That's the cool thing about learning physics and chemistry as well. I would suggest that you all go learn some chemistry. The way I did it was, I mean, I learned physics, did geophysics, then taught chemistry for 12 years and AP chemistry and all that, but still loved the physics. Then went back and got a master's emphasizing physics and science ed. And so then I got to see why all that chemistry works from a physics point of view. The best class I ever took was a class called PChem in grad school. PChem, it's physical chemistry. You have a big lab with it too, but you learn all the physics of chemistry, and that's fascinating. Okay. Now we'll come back tomorrow and we'll work 5C and 6. So don't worry about those. Those aren't homework. Okay, so we talk. Oh, and then we talked about the Concorde, and that's what that article. I'm not gonna waste your time here talking about it. Well, it's not a waste of time, but we did talk about the Concorde. It's French. There's an E on the end there. Not the SR7, not the same thing, but the Concorde was a jet set. No one knew what the Concorde was, so I thought, well, we ought to talk about it. The last time it flew was like 2003, so before you were born, most of you. Probably all of you. Anyway, so the Concorde was a supersonic jet, and in the article, it's really cool looking jet, and they asked, well, what about a commercial plane? Why can't we just go faster? And we can. The Concorde goes at Mach 2, up to Mach 2, versus a 747, which is going about Mach 0.7. So you get there twice, 2 or 3 times faster. Maybe 3 times faster in a Concorde. So if you're going from Paris to the main route was Paris to New York City. There's also London. But the problem with the Concorde was it would break sound barriers and shock waves. When you break the sound barrier, it sends out a shock wave. And so it's a big sonic boom. And people got tired of that. Also, it had some spectacular crashes. And so it had some wheel issues, and so there's some landing gear issues and all this stuff. So they finally scrapped it. But that went above Mach 2. The thing was, it cost you $10,000. Someone asked if that's one way or two way. I don't remember. I just remember that stuck in my head. My goodness, this is $1980. Are you going to spend $10,000 on a flight? So it's sort of a status symbol. You say, well, I just got off the Concorde, you know. Got to impress got to keep people impressed. Anyway, it is no more, and apparently will not come back according to that article. So we didn't really talk about the homework for tonight. It's just more of the same. It's first, second, or third orange. And I will post keys on all this. I'll tell you what. Oh, I haven't assigned 5 and 6 yet. I'll just keep assigning this once it's all assigned. If it isn't making sense, then just table it, and eventually the key, by this weekend, the key will be posted. Didn't have time for that. We'll come back to that tomorrow. Okay, so we spent the rest of the time watching part of this video. This is Girl in the Jeep, and this is 213. Now this is due. This isn't a Dolphin thing. This is due on Sunday. Submit for 24 points, six points each, so 24 points. It's like, okay, these are trios, but they're like piecewise sort of trios. It's still, in other words, you're given a velocity versus time graph, and from there you have to plot the position versus time. So in third hour, we had a little extra time, so we started coloring them in. So you need to color these in like we did, like the finger dance stuff. So you color in the V versus T, and like you did in the last test, except that those are all flat, right? Flat, and then that caused you, this is so important because this, I really cannot emphasize how important this is. Because if you want to understand calculus next year, or maybe this year. If you understand calculus, you have integration. You have to understand this. This is considered graphical calculus. There's symbols for all this, and maybe we'll talk about it before the end of the semester, how to write this in an equation. There's a whole way to write this. That'd be cool. I'll make a note. Got so much to do. Anywho, so from this, you plot what the graph above looks like, what the X versus T would look like, okay? Now, we watched a video, about 5 minutes of a 24-minute video. And I'm not gonna sit there and have you watch a video with me, but I will show you where to go. The thing about this worksheet is, this could be, it is simple, a 24 simple points. If you cheat, quote, cheat, if you just watch the video, I answer all these questions. So you could just watch the video, right? But that's kind of dumb. That's short-term 24 points, but now you're going to lose, 50 points on tests. So that's not a smart way to live. So you want to learn it. So what I suggest you do is, first you try it, and probably tomorrow in class we'll do one of these together. We'll probably do like number 2 together. So if you want to wait on this and not do it till Sunday, you could wait until tomorrow to start this. We already have homework tonight. This is a long-term assignment. And then it's looking like we'll probably do number 2 in class. That looks good to me. We'll do 2 in class. So like it says on here, I'll blow this up. Go to the 9:10 mark. So it's user-friendly as far as the video you're watching. It tells you where to go to look. Here starts the 5:50 mark, then you go to the 13:45 mark. So just to see if you did it right. And then if you didn't do it right, you can go back and listen to me. This is something we did, 10 years ago or so. There was a musical going on or something, so there wasn't many kids in class. So I said, well, let's just do some help videos. I'll show you what I mean, and then we'll stop. It was a pretty mellow day. Okay, we are recording, yes. Okay, so I'm gonna show you, here we go. So if you go to the Canvas and you go up here to the announcements, it says, here's the link to the Girl in the Jeep video. Click on that. There it is. Click on that. I can make that look more like an app. Oh, and if you just want to go right to the YouTube, if you go right to my YouTube channel, just search Girl in Jeep. Yes. Here I am working this problem. And so you can, fast forward back and forth. And it's a cool little program we had that it doesn't work with today's technology. It was an old style program, and they never updated it to go with like Macs and stuff. So I had to film me doing it. So from 0 to 135 miles an hour in 10 seconds. So that's a heck of a Jeep. All right. So that's the Girl in the Jeep there. And I'm not going to sit and bore you watching this right now, but that's what you look at. And you watch that video, it'll become clear. I explain it fairly thoroughly on there. And then you do the homework, and that's due Sunday, midnight. That's probably the last assignment we'll have, other than just Dolphin Points. That's probably the last time we'll do that. Then other than take-home tests, Okay, so I think that's it for today. We didn't get there. We'll do this tomorrow. We have a minute or two. Any other questions before we sign off here? Is that us? We just had we had a lot of questions in class today. It was nice. Kids were actually asking questions, which was cool.
I have a question.
Yeah.
So for number 1, are you gonna go over that later, or
you're talking about this number 1 on
2.12?
Well, I kind of rushed through it, and now we're not in such a big hurry. So let's go ahead and knock it out real quick, okay?
Okay.
And if you want to drop off, you can. If you think you already understand it, it's the last thing we'll do. Okay, it's found that the position of blah 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 blah. Okay, so the equation is x equals 2t squared. Oh, oops, we're not sharing the screen.
Yeah.
Let me share the screen. share. Okay. So yeah, so the thing is x equals 2t squared. So we'll just do a little t chart here. So if it's 0, 0, if t is 1, x is 2, if t is 2, x is 8, if t is 3, x is 18. And Jacob, who's a very observant student, country after class said, you know, this is the same as the in chemistry as how the electrons fill up the orbitals. That's just coincidence. I thought that was a good observation. You know, if you've had Chem 1, you know, you did that. You do the 2, 8, 18. Okay. Bohr model. All right, so 0, 0, 1 second, I'm at 2. At 2 seconds, I'm at 8. At 3 seconds, I'm at 18. Okay. And then you're connecting those up into a parabola, parabolically. We know it's parabolic because it's 2t squared. So we know we're dealing with a trio because remember, trio, the x is to the second order. Yeah, so, okay. So then it says, first says find out what the average velocity is during the 3 second interval. That's what I was showing Eric. I said, okay, so now we just take a ruler and we connect up the beginning and the end, 0 seconds and 3 seconds. And this is the slope of this line will be, slope of that line is the secant, and the secant slope is always V bar. So V bar ends up being, it looks like 18 over 3 or 6 centimeters per second. Okay. But that's not very good. We don't want average velocity. We want to know what's going on instantaneously. So B says draw the tangent lines at 1 second and 2 seconds. Okay, so I get my purple. I'm going to do it, no, not purple. I'll do green. And so at 1 second, now remember with a tangent line, I'll blow this up a little bit because a tangent line is going to kiss that, it's going to kiss the curve at 1 point. And this is why you need calculus, because why Newton had to invent calculus, because you don't know. I don't know if that's right or not. It looks okay, but is that the right kiss? Maybe it's a little bit different. And then at 2, I kiss the curve. I touch it at 1 point. And that's the tangent at 2. And then you find the slope of each one of those. So you find the slope of this green line here, and then find the slope of this green line here. And that'll be, that first slope will be this will be your V at 1, and this other slope will be V at 2 seconds. And then what's it say to do? Draw that, estimate the instantaneous velocities. Boom, that's all you got to do. So once you find the slopes, you're done. Now, I'll show you a little trick, and we'll learn this trick later, but once you learn calculus, you learn the power rule. Here's something kind of cool. This will be a Zoom special here, but we'll learn it later, but you take this, all you do with the power rule is you pull this down, multiply by that, you get V then equals 4 times T. This is what Newton figured out. And so that tells you what the velocity is at any given time. So if I plug in 1, that means I know that my slope, my V1 should be 4. Just ignore me if that bothers you. We'll get to it later. But sometimes people are interested. That equals 4 centimeters per second. And then if I plug in 2 for time, I get 8. So my velocity went from 4 to 8 centimeters per second. It seems like magic. Calculus is 90% algebra and about 10% magic. But that's what turns calculus into poetry. Okay. Is that it?
Yeah, that's it. Thank you.
Okay. So we are at about 45 minutes here. So I guess we'll call her good. Most people have dropped off. Okay. Well, I guess let me stop sharing. Unless Takaki has a question, then we're going to call her good. You two hung on there. All right. I don't know what to do yet about the Dolphin Points. Worst case scenario, we'll just ignore them for virtual kids. Unless you guys can think of something smarter. Okay, so I'll talk to you guys. Talk to you later. See you tomorrow.
See
Bye-bye.
ya.
Bye.